God, it's raining like crazy, cats and dogs.
Hello and welcome to episode 11 of Slack Chats with your hosts Stuart Winter, that's me, and Phil. Hello Phil,
Hello, Stuart.
how are you doing?
I'm very well, thanks. How's yourself?
It's all good.
hmm
I'm Stuart Winter. I'm the architect and developer of the Slackware ARM ports, and Phil is the maintainer of SARPI, which is the Slackware ARM on a Raspberry Pi project. And this podcast is talking about mostly Slackware ARM, but also the wider Slackware ecosystem. So last time, Phil, we had our first guest, Angel Montanez. It was a really good chat. I was just finishing the editing of that, putting that online. So yeah, that was really good. So if anybody else wants to come in and talk to us about what how they found the distribution and why they keep coming back to it and what they like about it, we're all up for that. Just let us know on the Linux Questions forum, and we can take it from there. So Phil, what have you been up to?
Recently, I have built Google Golang and Docker to run on Slackware ARM, just because there didn't seem to be many people going in that direction. And I thought it would be good because Docker's fairly new in terms of popularity, and it's something that I knew nothing about.
Yeah, there's a lot of noise around Docker. There has been for quite a while, for a few years at least. So do you want to talk a little bit about just a little brief bit about what Docker is?
I use basic terminology because that's what I understand. And people talk about artifacts and layers and principles and all kinds of things that don't make sense to me. So I'll be very basic with this. Docker allows you to run basically a shell. It's called a container. But what it allows you to do, it runs the container on an operating system level where you can run an operating system within that container. It uses the running kernel of the system. But within the container itself, you are not God. You are root, but you are not God. There are certain limitations, obviously, that do not allow you to interfere with the host system. So within that environment, limitations as they are, it's still a very viable option for running and testing software. Not just an operating system, but any project that you have, you can run it in a container without any fear of doing any damage to the host operating system or files whatsoever. I think if you were asking for a personal opinion, that is what Docker is useful for. And it's quicker than installing an OS and setting up your scripts or files. You can run a Docker container in a few seconds, and you can have an operating system up and running with everything configured in those few seconds. That's the beauty of it, speed.
Exactly, yeah. So I mean, we were talking earlier about this before we started recording the podcast. And so, for example, I've got a Docker image on my laptop, which the Docker image is provided by some of the department in the business I work for, really so the technical consultants and some of the field staff can be able to easily use the types of tools that our customers do. So for example, I've got a slightly different setup to what you have, because you're running the same actual operating system, whereas I've got macOS and the Docker image is running an Ubuntu Linux distribution. So what they're doing is they're providing a already installed Ubuntu, a very small, a few gigabytes in size Ubuntu image, and it has all of the vendor tools that we need to integrate with our platform. So so basically you download this image, you just tell Docker to run it, and then you have a shell, bash shell pops up, and you're able to instantly use all of the vendor tools to access the platform. So we can work really quickly with that. And it just means that somebody internally inside the business is maintaining that. So they're making sure they do all the package updates and stuff, and they keep pushing out a new Docker image every now and then. So it's really, really good, because you don't want to go and install an entire operating system, go through all of the rigmarole to show customers something or to test something. And then in other examples, what you can be doing is one of the particularly useful aspects I know that people have used Docker and similar technologies. Docker's one of a few, and it's not exactly a new concept either. I mean, cheroots have been around like since Unix, the Unix day has been there for decades. So the concept is certainly not new. But one of the things that other people use it for is that they can, and we looked at doing this at Cisco as well, but not using Docker because it wasn't around and we had a different type of system there. But one of the things that we were looking at was when we had our production systems. So these would be, in our case, it was proxy servers and those kinds of things, and the sort of core systems that would run the NTP services, some other management systems and authentication systems. And one of the things that we needed our developers to have, our in-house developers, was essentially their own version of production, so that they could go and start working on some aspect of it. Let's say it's your authentication system, and that authentication system is plugged into all the other systems in production. And so you can't let them loose on production, obviously. What we did was here's your production image and a few other images. And in the production image, what we'd actually done was, we've got hundreds of machines in production. But we said, okay, here's the production image here's the production. You've got this image, and inside it you've got the authentication system. Inside it you've got all the things in production in one image, and then it was configured so that it all worked together. And what that meant was that we could say, okay, here's because we had 2-week sprint windows. Okay, here's the 2-week sprint window version of production. And then the developer wouldn't need to install anything. They just grab the image and then put it into their virtual machine and boot it. And that's what we did in those days. Yeah. So the developers had their own virtual machine of production. And so they could do whatever they want with it, test it, develop it. And that's similar to Docker. So the idea is that you have your version of software and package, basically your deployable. I guess I'm not sure if artifacts is the right term. You've already mentioned it. I don't know if I'm using it wrong in Docker nomenclature, but basically you'd say, okay, well, my production instance of X consists of all of these packages, so I'm going to go and install the latest versions of them, package it up in a Docker container and ship it, and that's it. Use that, and that way it's a lot. They can literally, as I do, just download it and then run it. And that's it. So they don't need to install anything new. You don't need to go and do a package update. They just get what you give them and they use it. So I think it's a really good. I could see that being quite useful for building, in some respects, for building Slackware packages. If you don't want to destroy or you don't want to pollute the the distribution.
Exactly.
And in my case, we're not concerned about that because my build systems are purely for building. Yeah. Their production use is building things, but for people who don't have that kind of setup, I could see that would be quite useful. So, okay, that's a bit of a description of it. So, what's your use case then? What are you looking to get out of it?
On a personal level, I want to know what Docker is good for, because, as you quite rightly said, there's a lot of hype. Is what I would describe it as around Docker, and it seems to be a solution that many people are taking under the wing. And I thought, I must be missing out on something. I really need to know what it's all about. And I started to investigate Docker because we were thinking of running it on FatDog on the server where we host the SAPI project. So it is something that I really need to know. And then I found that there wasn't any support really for Slackware ARM running Docker. I discovered some work from Vincent Batts, which was helpful, to be honest. But I had trouble building the packages enabled to get Docker to run, but it managed it eventually. So yeah, it for me personally, I need to explore Docker, and I want to do that on Slackware ARM, which leads me on to the reason why I want to get to know it is because I think it would be useful for users to be able to download a Docker file, import the Docker file, the Slackware ARM Docker file, and just run the system. Especially say somebody on Raspbian who's bought a Raspberry Pi, installed Raspbian and just stuck with that. Certainly if they're into containers and Docker in particular, then it would be very easy, I think, to make a Docker file so they could download it and run it in that way.
Yeah, it sounds good to me. Yeah. Why not?
It doesn't have to be Raspbian. It can be any ARM device that runs Docker, because it's simple to import the file and just run it.
Okay.
And that way users would, I don't know, maybe for not just new users, but old users who've gone onto other systems and think, hey, there's a Slackware ARM Docker file, I'll install that because I used to like Slackware. I've heard a lot of people say that. So, it just, I think, given that there's very little support currently, I mean, there has been in the past, in years gone by, there's been Docker support for Slackware, but currently there doesn't seem to be a lot of people making any effort, and certainly for Slackware ARM, there's no effort at all. So I want to fill that hole.
Okay, so what do you need to put out then? Is it like a Docker container image or?
Yeah, it's basically you create a Docker image, you upload that to hub.docker.com, and then you share the Docker file. And it's the Docker file that works with the image that's been uploaded, and that's how you get the system installed. As I understand it, it's I'm still learning this. It's a weird, convoluted way of configuring software, but like everything else, it's been designed with whatever they need in mind, and there's no sort of standard. I'm learning more day by day, and it will get easier.
Yeah, there's lots of these different tools around. You have to go and spend time figuring out how exactly to set them up. Yeah. Okay, so you've already got Docker working. Is that right? Yeah.
Yes, I got, it's Slackware ARM current, and I've got Golang and Docker, the latest versions built for Slackware ARM current, and I've installed that. And you might think, why are you running the Slackware ARM container in Slackware ARM? It's purely for development purposes. I want to be able to create a Docker file that other people can use, not necessarily on Slackware ARM. But it had to be tested, and it hasn't been fully tested yet. So yeah, before I would think about going public with anything, of course, I'd iron out all the niggles and make sure it was working properly.
Okay, yeah. So you've got a couple of targets then. So the first one is, for example, Raspbian, that people will be able to download the Docker. They'll be able to download the Docker container on Raspbian, do whatever they need to do to get Docker running on Raspbian, and then they'll be able to boot in Slackware ARM and have a play around with that.
Mm-hmm.
Okay,
that's exactly it. Yeah.
Yeah. Okay. So you've already got it working. And then you can if you want to, you can document how to get it working on Slackware ARM as well, in case anyone wants to run a Docker container inside of Slackware ARM.
Absolutely, yeah. What use is software without instructions?
Yeah, it needs to have some instructions on it.
Yeah.
So what's the current status then?
The current status is I'm going to be annoying you with questions soon.
I saw it's taken for granted that.
The status of it at the moment is I have a Docker container with your current mini root installed, and I'm planning for the future. I'm putting myself in somebody else's shoes and thinking, right, I've got a mini root file system of Slackware ARM.
Mm-hmm.
Where do I go from here? What exactly do I do to get the operating system fully installed with all the packages. That's exactly where I am.
Okay.
And I'm thinking about the user who says, no, I don't want that. I don't want a fully installed Slackware ARM. I want these packages because these packages allow me to do X, Y, Z. For
Right.
those users, I'm thinking about those users too. So I want to give people a choice, and
Right.
I'm limited because I obviously can't run the Slackware ARM installer in a container. So this is where I'm at. That's exactly where I'm at.
Right, okay, yeah. So it doesn't, yeah, you're right. So it doesn't make sense to run the installer. That's not what Docker's about. Docker's about providing something that's been packaged specifically for a reason, for a target. So that, yeah, so the installer's out of the question. Okay, so you've taken the mini roots as a base, as a good base point, because that's actually a lot, that is a real operating system. It's got the base set of packages that you need to get networking and do a bit of diagnosis and bootstrap a system. But in terms of the users, people wanting packages this, that, and the other, given the way that dependencies work in Slackware, and the recommended installation for Slackware is a full installation, and that actually deals with the dependency issue. And particularly if it would be possible. Well, actually, no, not really. I was going to say it'd be possible to once you start building Docker images for a particular version of Slackware, then that makes it easier. But because it's basically here's the version of 15.0. All you need to do is just up to keep the thing up to date. But with current, that's a different story anyway, because even if users knew exactly which packages they wanted. I know that, for example, now in the most recent batch I've just been processing, say, for example, Network Manager needs a new has a new dependency that's just been introduced. So you're going to always have to have a full installation of Slackware. And if people want to, they can go and remove package things that they know that they can get away with remove packaging without breaking anything. That's the approach I would take, because other than that, people are going to end up with a broken system anyway at some point. In fact, not even at some point. They're going to end up with one pretty quickly, if not immediately. So I would always just suggest that you just make it so that the option is that obviously you can't distribute a Docker image of a full Slackware installation, because that would be massive. I mean, you could do that, but that would be massive, and that doesn't make sense. But I would imagine that the best course of action would be to use the mini route as you're already doing, and then perhaps use the Slack package tool to upgrade everything that's in there and add in anything new. So that means, in particular for current, that's yes, that's what I would do. I suggest for the once 15.0 is released, the recommended installation would be, here's the container, it's got a base set of packages in there. And from there, all you need to do is run Slack package and update. So anything that's, no, actually, forget that. I would say because that's, I'd say that the installation instructions are quite straightforward. They boot the container, it has a mini root base set of packages in it, and then, so I would say that the installation documents would do something, be quite simple, and say, okay, you install, whether it's a Slackware release or it's current, that they install with the mini root there is, and then they use Slack package upgrade to upgrade what's there and install anything that's not currently upgraded, because that's not present. So install anything that's not currently present, and that will bring them to a full installation of Slackware that's up to date. And that's because that's the recommended way of having a Slackware installation.
Right.
Yeah,
so
that's what
include Slack package in the Docker image.
Yeah, isn't Slack package actually? Is it in the mini root already? It might not be actually.
I think it is. Think it is. Let me have a look. var log packages, isn't it?
Var lib.
Var lib
package tool, PKG tool packages.
Oh, I'm going through the shortcut. You're You're giving me the full.
No, that's because it's changed. Package tool's changed. It's going to change in 15.0. It already has.
Right.
In current,
Really?
it's var lib package tool, and then the directories in. Yeah, was it the
Slack
14.24?
package, yes, Stuart. Slack package 2.83.0
Is in
is
there.
installed. Beautiful.
Yeah, that's what I thought.
That means you can do a Slack package install Slackware, and it will just, without asking you, install the full
Okay.
complement of packages. That is brilliant. Yes,
Yeah, that's what I would
that is the
suggest.
way forward.
Yep. Just make sure that the Docker, whatever the container or the installation instructions, just make it so that there is actually enough space for a full installation.
Yes.
In the container image, or however it works. I'm not familiar enough with Docker
Yeah.
to know that, but
From my experience, when you start Docker, the image size is not specified, or at least I don't specify an image size, and it uses whatever free space I've got for that image. And so if I've got 40 gigabytes free on my hard drive, it doesn't make the image size 40 gigabytes. It expands the image as you use it and make it bigger up to the amount of free space that you've got. So I don't know, people with Orange Pis or Raspberry Pis should be fine just to install the Docker file and run it, because it should run with the same parameters as what I'm using.
Yeah, okay. I think you just need to check whether it's to do, because if it works anything like VirtualBox or the Docker desktop that I have on my Mac, you have the actual image file, as in if you look at the file size of the Docker container, it's say 5 gigs, but the reserved space, like the actual image itself, only takes 5 gigs because that's all that's in the image. It's not like you've got an image and it's padded. So, but it means that there's an upper limit to the, so you can have it so that the upper limit of the image, say, is say 20 gigs, but it only currently consumes 5 gigs because that's all that's there. So in other words, you've got Docker said, it might be that Docker says, okay, well, I've got an image and it says that the size of it can be 20 gigs, but it's only currently using 5. So you'll only show your image is using 5 gigs when you look at it inside the host operating system.
Mm-hmm.
Whereas, so you just need to, if that's the case, you just need to make sure that the image, the Docker container image is the Docker container. Let's use the proper term. The Docker container has enough space to accommodate the full installation, which I think is about my Slackware ARM box here says that the one that I don't think has been used for building anything yet. So it says 11 gigs has been used.
Right. I'll tell you exactly how big the Docker image is with a full installation of Slackware ARM. Just give me a moment.
Should be about 12 gigs or 11 gigs.
I'm looking for a file I can't find because I'm on the wrong drive, I think.
Yeah, I would go and say probably at least, okay, so the image itself you're going to distribute, the container is only going to be a few hundred megs, right? But it's just a case of making sure that there's enough.
It's going to be about 305 megabytes is the Docker file.
Yeah.
But the full image, a tarred archive of a full install of Slackware in a container is, call it 11 gigs.
That's what I've got here. But that would probably be without KDE-I, which is the internationalization packages. But yeah.
Oh, this is everything. This is absolutely every package, including the language,
really?
the KDE language. Yeah, we installed absolutely everything, so nothing was missing. So if somebody in China or Japan or wherever wanted to use that, it would be pretty useless anyway, because I don't know of a way to run X within a container, but at least they've got it. If they were building software that required it, they'd have the package installed, is what I mean.
Okay, but so for all intents and purposes, it's about 11 gig to have a full install. Yeah. Okay. Yeah, so that's what I would do. I think that makes the most sense, and it's also the easiest thing to do. Yeah.
Yeah, it is. It is. Um, but yeah, it's interesting because containers offer an environment where I'm into building packages and developing software. You will understand what that's all about. But Docker gives me a means by doing it without any risk. Because if it does mess up, I can put everything back as it was in seconds. It really
Yep.
is very, very fast.
Yeah. Yeah.
And I have built the first test that I ever did. I built a SAPI batch of files in the container, and to my surprise, it was a little bit quicker than it was on the host system. I don't know why, but it was. I started off with a mini root, and I ran the SAPI build scripts, and each time it came up with an error, I fixed it. I installed a package, and it took 23
Okay.
packages and a git ignore certificate command, and now I can build SAPI stuff in a container under Slackware ARM. So it was a good test, and based on the results of that, I'm keen to explore what else Docker may be useful for, and maybe other people will too. If they're into developing their own stuff, especially with Slackware, this is a perfect system to use. And if they're just interested in using
Mm.
Slackware to see what it's all about, then Slackware ARM is exactly the same as mainstream Slackware, except for the ARM
Yeah.
bits. So it really is a good medium on which people can use for development without any risks whatsoever, and B, to try Slackware without encroaching on the host OS.
Yeah. I think that's one of the key things there. Yeah. Cool. Well, yeah. Okay. But it sounds like you've got a plan then, and you can move
Mm,
forwards with that.
mm. Yeah, thanks for the advice and the tips,
Oh, you're
because
welcome.
it does help getting somebody else's opinion. You can Google all you like, but at the end of the day, you need experience, and Google doesn't offer you a lot of experience. It just offers you information. So, I might ask you about something. You say, oh, yeah, you can build this, but you need to do this first. And like with Vincent Batt's Docker information, the one thing he said was you need to install Golang first. So I had to build Golang, which wasn't easy. It took quite a few hours to get it to build
Mm.
before I could build Docker, and building Docker wasn't easy either. So, the differences between information on the internet to get stuff done
Oh, yeah.
can be black and white and grey and all shades of the rainbow. But at the end of the day, it's your experience. If somebody came to me and said, how did you build Golang? I'd just go to the notes that I created and tell them. But you don't get that from Google. You do this, do that, type this
Yeah.
in, hit enter, and there your package will be there. But what if it isn't there? You know.
Yeah, I mean, I'm sure most people have. If you're doing something like this, you'll pretty much have the same experiences. Even if you're not building packages, but you're setting something up, you're configuring some kind of tool or some service or something like that. And that reminds me actually when I was looking at the Slackware from Scratch thread on the Linux questions forum. So at one point I was following along on that and gave a few of my insights on it. And the thing is that you're never actually starting from scratch anyway. So there's no, for example, like I know that I don't know if it's still the case, but it probably is that the TCP/IP package in Slackware in the N series can't be bootstrapped. It can't be built from scratch because it relies on the package already being installed before you can before
Right.
you can build it.
Okay.
So the ARM version doesn't, because I didn't like that dependency there, so I fixed that. But there are lots of other things like that, and also whenever you're really, even if you want to say it's starting from scratch, you're starting from scratch from a different point in time. And so the packages and the build order is going to change depending on what the dependencies are.
Yeah.
So so I mean, even if you have this documentation, you come along only even a few months or weeks later, and it could be that it simply doesn't apply anymore. Which is, one of the reasons actually when I first started porting Slackware, I used to make notes like you're doing, and in the end I just ditched it because I realised that it was constantly, it just doesn't work that way. You can get to a certain point, and then you realise that, like Pat told me, it's like you just built everything over and over and over and over and over and over, yeah. And that's how you ended up with Slackware. So I did the same thing. It was easier that way. That's what I do now as well. But you were brought on. I remember we talked about this recently. So we're talking here about if people are building packages and things for Slackware ARM, and we got on to talking about the architecture naming scheme, or the naming label in the packages.
Yes.
So, for example, foo, the standard packaging format name, which is foo-version-architecture-build number dot, most of the time TXZ. For Slackware. So, for example, foo-1.0-arm-1.txz. You've been labeling it as ARM version of ARM v7 or something like that, hadn't you?
Yes.
And I said to you, I'd explain what the actual architecture naming convention is, because I haven't actually documented it anywhere, and there was a bit of confusion around how they should be named. This is also similar, and in some cases actually is identical to the x86 Slackware, is that the ARM label is relative to a particular release of Slackware, right? So it just means that the package, the software is compiled to the target baseline of the architecture, right? What that means is that if you look at GCC, there's some options here. I'm not going to read them out. I'll document this later and put it up on I'll post it to the Linux questions forum for later. But so in Slackware ARM, the ARM label of the package, it really is just relative to a particular release of Slackware, right? So if you have bash-4.0-arm-1.txz and you took it from Slackware ARM current, or you took it from Slackware ARM 14.2, all it really means is that it's compiled for the baseline architecture. So in the case of what is going to be Slackware ARM 15, that's going to be ARM v7. Uh-huh. There's a few other bits as well in there, but that's ARM v7. And for Slackware ARM 14.2, it was ARM v5t. Right. So that's what ARM means in the package file name. It just means that if you took it from one of those releases, it was compiled for the baseline of the architecture, and those baselines are available on the website. This is no different from having the font the package like on the i586, right? If you have or x86-64, if you have bash-1.0-i586-1.txz, you can't tell which version of Slackware that's from, can you? There's no way of knowing, right? So this is the thing. Whether it's Slackware ARM 14.2 or it's current, the actual package file name, the architecture name, is still the same. It's just ARM. I haven't changed it. So some of the distributions do. They've like Debian ARM hard floating point. They've got theirs is called ARM HF. That's right. And then the software floating point was called ARM EL. And then the one before that was called ARM. So I just decided to call them ARM all the way through because I wasn't going to maintain old ABI, versions of the ARM port. Uh-huh. Right. So there are only a couple of exceptions to that, which is that with in Slackware ARM 14.2, there were some packages like Firefox that would build, but they would only build on something that was greater than or equal to ARM v6, which would have been the Raspberry Pi. So I compiled Firefox for an ARM v6 target because I could. But I didn't distribute it inside. For example, if you look at 14.2, there's no Firefox in there. There's no updates for Firefox because I took it out because it it doesn't build. But I made it available outside of the main tree because I thought it might be useful. But in that case, and you can find this in the unsupported directory on the FTP site. So, it was Mozilla-Firefox-34 blah, 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 -ARM v6j-1 _ Slack 14.2. .txz, because the reason why I'd rename the architecture there was because it was for a particular version of Slackware, but it would not run on the baseline architecture. You couldn't run it on ARM v5 because it contained instructions for ARM v6, some instructions for ARM v6, so it just wouldn't run. So I couldn't distribute it. Those are the only exceptions that I make, is where I'm building something that simply, isn't is outside of the norm, pretty much. That's it. And then, like, for example, with software, with the software floating point port versus hardware floating point port, there is no distinction. I don't make a distinction because the key is to do with the Slackware version. It's not to do with the ABI. It's not. It barely even really. It's the architecture and it's the version. But if you're looking at Slackware ARM and you're looking at Slackware x86, well, you're looking at those. They're two different entities anyway. So it's really then about the version of Slackware ARM, because the ABI is different, right? Because basically one of the reason why this is, and I think some people have got quite confused about this, is that basically the ABI, it means application binary interface, and it's not as simple as this, but essentially it defines the structures and conventions about how the components, in our case of the operating system, all the binaries and libraries and all that stuff that comprise the packages, it defines the way that those components speak to each other. How do they interact? How should the messaging look like? So the thing is, you can't run because the ABI for what will be 15.0 is completely incompatible with 14.2. It doesn't matter whether it's hard float or not. It's completely irrelevant. It's just an incompatible ABI. And so it doesn't matter what the ABI is called. It's all you really need to do is, as far as if you're building packages, the people who are building packages just need to know that the architecture is called ARM, and they should, if they're releasing a package of 14.2, it should be -ARM-_1 for the build number _slack 14.2. If it's for 15.0, it should be 1_15.0. That's the easiest way of doing it, and I'd recommend doing that for the x86 or x86-64 as well. The other reason, it's not just about ABIs either. So in the case, it's also to do with libraries. If you're building a package for Slackware ARM or Slackware x86 or any distribution, it doesn't matter. If you'll build it and it will find what's in the environment around it. It'll find. If you run a configure script, you can tell it, build with this, build without that, build with PAM, don't build with this, do with that, build with this. But also what it'll often do is, if you don't explicitly enable or disable certain bits of the certain features of that software, it will look in the environment it's been compiled in, which in our case is a full installation of Slackware, and it will find or not find other parts of other things around it. So for example, it wants can the bit of software read PNGs? Can it, if it's an image, if it's a bit of software that wants to be able to render images, it'll want to know if it can render PNG images. So it will look to see if it can find PNG on the system. If it does, it'll add support for it, even if you don't tell it to. And what that means is that if there's a certain version of I'm just using an example of libpng, but if there's a certain version of libpng, it will compile for that version of libpng. And that's that. But when libpng gets upgraded in a future version of Slackware or in a different, it means that software probably won't work anymore. So you can't say I'll have a version of a package of 14.2 and run it on current, even in x86, where the ABI hasn't changed, but the versions of packages, the supporting framework for that package has changed. So you can't expect it to work. It might do, but you can't expect it to work, and you shouldn't. So you should label your packages according to the version of Slackware rather than the architecture. Well, you know what I mean. In the case of ARM, you just call them ARM. In the case of
I do both, because I'm building them on an ARM v7 system, and then I also name the package either it's Slackware Slack current. It'll be ARM v7 _ build number _ build number underscore slack current for the ARM v7.
Right.
For the 14.2, they are just called ARM, and that helps me to understand which is which, because I have quite a few packages to sort out.
Oh, right. Okay. But even with current, current's evolving, right? So the current from a month ago isn't the same as if someone found an old current that was actually 14.2 current or pre 14.2, then they wouldn't be able to run your package even if they had an ARM v7 machine because the ABI is different.
Yeah.
So what I'm saying is using, unless there's an exception, like I can't imagine, I mean, well, actually, yeah, I was going to say I can't imagine an exception where a user would need to use a different architecture, but that's not the case. But yeah, I could see if there's no point in you calling it ARM v7 because that's the baseline for 15.0 anyway. So it's kind of a superfluous bit of data. Whereas I wouldn't label them current either because the current evolves. What I would say is that the current is relative to the previous release of Slackware. So if you look at, for example, the etc. Slackware dash release, if it's when Patrick does an upgrade, does a release of Slackware, it'll say Slackware 14.2 in it. But then once it turns into current, he adds a plus. He suffixes the number with a plus. So if you look on a Slackware current machine now that's post 14.2, it'll say Slackware 14.2 plus.
Plus, yeah.
And so you'll know, any person will know that, okay, that's current. It's greater than 14.2. It doesn't tell you when, of course. It could have been last week, it could have been 2 years ago. But at least it tells you, okay, well, it's in the case of Slackware ARM, that's going to be, it's going to be after the ABI is going to be incompatible. Well, it doesn't necessarily tell you that, actually. You need to know a bit more. But I'll tell you what I'll do is I'll write that up and then I'll post that on there to the Linux Questions forum.
Yeah.
Because it's easier to look at than it is to listen to the podcast and try and figure it out, I think.
Yeah.
It's pretty straightforward.
I put the date in there as well, so I like to cover it in all areas, just for people who don't necessarily care what version of package they're installing, as long as it's an update on whatever they've got installed.
Oh, I see. But equally, then you could just have an increment the build number. That's the purpose of the build number.
Yeah, I could.
You could, yeah.
I could. You see, the way I build it, I'm lazy, Stuart. On your packages, you will have like GCC 9.20 build 5 or build 7, and mine are always 1. Mine are always 1 because that's what I've set them as in the SAPI build scripts, and the Slackware 14.2 builds are always 2, and that's because when I used to get to the website uploading them, and I have to differentiate between Slackware current and Slackware 14.2 packages, and I do that with a 1 and a 2. And I never ever build more than once, to be honest, unless there's a problem, in which case I fix the problem and rebuild. But usually the problems are worked out before I do the build, so not much chance or opportunity to do rebuilds.
Oh, right. Okay. You mean, okay. Yeah, I think I know what you mean. I mean, because they're included as part of an image or something like that. Is that what you mean? Or I'm not sure why you couldn't rebuild them.
Because I don't need to. If, for example, somebody on the forum says my wireless has stopped working in the latest version of the kernel that you've released, then I will go back and test and do everything I need to do to ensure that it either is or isn't working. If it does need fixing, I'll fix it and then I'll build. And then I'll test the build. So usually after I fixed it and I build it, it works. So there's not much, right. There's no need to go back and rebuild it unless it doesn't work, which what I'm trying to say is doesn't happen very often.
Right, but if it did, then you'd increment the build number. Right. Otherwise, how would anyone?
No.
Okay.
No. Because then if I uploaded to the website packages with a build number of 3, the website wouldn't know what they were. It's a sloppy system, but that's how it works. That's how it's worked for years. When you mentioned 15, when 15 comes out, there are massive revisions planned. And yeah, we're gonna.
Oh, are you saying it's to do with? Are you saying it's really to do with the content? I'm not sure if it is a content management system, but essentially the content management system you don't. So you've got your HTML that refers to something, whereas I've just got an FTP site.
Oh, Stuart, yeah, I built it by hand in a text editor, and I maintain it by hand in a text editor. There's absolutely no WordPress or Dreamweaver or anything like that involved. If you go to the SAPI website and view the source, every single bit of pixels that you see on that document is done by hand.
I think you should do something with Slack package with that, because that's so much easier. You can just have a little stanza inside of the Slack package config, and just say point it to this repository, and then if there's a problem, just say, well, upgrade it here, and it'll download the latest version. You don't need to maintain any of it. I mean, I certainly wouldn't be maintaining the lists of files on a piece of HTML or inside of a content management system.
Oh no, I have it's PHP driven. Right. And all I change when I upload the file, all I change is the version and the date. So if it's kernel version 5421 and I'm uploading 5422, I just change the 21 into 22 and then put the date of the build on it and then upload the files, and that automatically picks up the new file names.
Okay.
I see. Okay. Yes, I could program in the build number. In fact, I have, but I haven't expanded on it. It would take maybe an hour or so to change all that code over. So it could be done, but like I say, the builds, whenever I do a SAPI build, it's always a one run, because I'm always testing before I do the final build anyway. So when I do the final build that gets released, there are no problems.
Right. Cool. Yeah, let me know how you get on with Docker. I'd be really interested to see how that pans out.
Yeah, it's cool stuff. I mean, it is modern and not necessarily everything that everybody wants, but if you're into that kind of thing, it will be useful, and it's great to run on Slackware.
Yeah, I've not seen it myself, but I think it'll be really good to also help easily get people into the community.
Yeah.
Cool. Let's wrap this one up then, Phil. Okay. So that's the end of episode 11. So that's goodbye from me.
And a very goodbye from me.